June 18, paper 2, variant 3. Question 1. Length of cotton is measured between 2 points on a ruler. When the length of cotton is wound closely around the pen, it goes around 6 times. What is the distance once around the pen? Goes around 6 times. What is the distance once around the pen? Can I find the distance, first of all, of the whole length of this piece of cotton? Yes, I can. It started off at 2.4 and ended at 15.6. The distance would be 15.6 minus 2.4, which is 13.2 centimeters. This is the distance round 6 times. If I want it round once, so I will divide by 6, giving me a total length of 2.2 centimeters. Question 2. When does an object falling vertically through air reach the terminal velocity? When the weight is equal to the air resistance. When the acceleration becomes negative, no becomes equal to g, air resistance is equal to the weight. Yes. A sprinter runs a 100-meter race in a straight line. The table shows his speed changes with the time in the first 5 seconds of the race. What is the average acceleration between 2 and 3? Can I find the acceleration between time 2 and 3? Can I find this acceleration? Yes, it would be 5.7 minus 4.1 divided by 3 minus 2. Divided by 3 minus 2, which is 1.6 meters per second squared. Which row shows the readings on the scale? The mass, would it be in newtons? Cannot be in newtons. If the mass is 60 kilograms, would the weight be 600 newtons? Yes, it would be 600 newtons. If you multiply by 10, if you multiply by 9.8, it would be slightly less. An object has a weight of 7,600 newtons with a gravitational field strength of 100. What is the mass? Weight equals mg, or m equals weight over g. So 7,600 divided by 100, which is 76 kilograms. A load is hung from a steel wire. The load is increased. The length of the wire increases until the limit of proportionality is reached. The load is now increased slightly. What happens when you exceed the limit of proportionality? The extension of the wire increases. Yes, it does increase. And the wire no longer obeys Hooke's law. Yes, that's the whole point of exceeding the limit of proportionality. If you exceed the limit of proportionality, you're no longer obeying Hooke's law. What is the weight of the ruler? Okay, so you have the 30, well, it's pivoted at the 30 centimeter mark. At the 0 centimeter mark, you have a 6 Newton weight. And then you have another 2 Newton weight hanging from the 70 centimeter mark. Can I find the weight? Yes. The weight would be acting at the 50 centimeter mark, right? The weight would be acting at this point downwards, right? At the 50 centimeter mark. How can I solve this question? Clockwise moments should be equal to the anti-clockwise moments. So we have 2 clockwise moments, the 2 Newton and the weight, and we only have 1 anti-clockwise moment, which is the 6 Newton force. So clockwise moments should be equal to the anti-clockwise moment. Force times perpendicular distance plus force times... The first force is the 2 Newton times the perpendicular distance times the perpendicular distance. This is 40, right? Plus weight times 20. This distance is 20. Plus weight times 20. This should be equal to 6 times 30, right? 6 times 30. So this is 180 weight times 20, and this is 80. Subtract 80, so W times 20 should be equal to 100. Therefore, W would be equal to 5 newtons. The weight is 5 newtons for this question. An astronaut orbits the Earth in a space station, which is a vector quantity. The mass, the speed, the temperature, the weight. Only the weight is a vector quantity. A visitor to a fairground throws a soft object of mass 0.12 kilograms at a coconut of mass 0.48 kilograms. Okay, so he throws an object, a smaller object, at a larger object. Okay, now the soft object stops moving. The soft object stops moving when it hits the coconut. In order to dislodge the coconut, it must be made to move at 0.10 meters per second. So the coconut, in order for the coconut to move, it must move at the speed of what? At the speed of 0.1 meters per second. What is the minimum speed with which the visitor threw the soft object at the coconut? It's a bit confusing. This question might be a bit confusing, but let's solve it and try to simplify this question. First of all, you have M1, right? I'll call this object M1. And the second object, the coconut, M2. The soft object stops moving when it hits the coconut. So after the collision, again, after the collision, the soft object, the small object, M1, stops moving. Therefore, V1, so you have M1 U1 plus M2 U2 equals M1 V1 plus M2 V2. V1 will now be equal to 0, right? V1 after the collision, it's equal to 0, right? The coconut was at rest. The coconut was at rest, right? So U2, the coconut was at rest. So let's write it down probably over here. So U2 should be equal to 0. Why? Because initially it was at rest. And then take care that 0.1 meters per second is the velocity of the coconut after it was hit. The velocity of the coconut after it was hit. So V2 would now be equal to 0.1 meters per second. Can I find U1? What is the minimum speed at which the visitor should throw the soft object? U1, the soft object. So let's write down the equation M1 U1 plus M2 U2. This is equal to M1 V1 plus M2 V2. U 2 was equal to 0, so I'll cancel out this one. And V1 was equal to 0, right? V1 was equal to 0. Why? Because it stops moving when it hits the coconut. So V1 was equal to 0. So just cancel out this one. What's M1 U1? M1 was 0.12, and I do not know U1. You need to find U1. Equals M2, which is 0.48 times v2, the final velocity of the second object, 0.1. If you solve for this equation, so divide by 0.12, this will give you a speed of 0.4 meters per second. The initial velocity of the soft object was 0.4 meters per second. An aircraft with a mass of 300,000 kilograms is flying at an altitude of 2,000 meters with a speed of 100 meters per second. What is the kinetic energy of the aircraft? Can I find the kinetic energy? Yes, half mv squared. Half times the mass, 300,000, times the velocity, 100 squared, giving you a huge value, 1.5 billion, okay? Or you can just write it down as 1.5 million kilojoules. 1.5 million kilojoules. I know it's times 10 to the power of 9, and you do not have any energies to the power of 9 here, but you can just write it down as million or times 10 to the power of 6 kilojoules. Which method of drying clothes has the least impact on the environment? The least impact would be just hanging them on a wash line. All of the others probably would use some sort of electricity or coal. Coal would affect the environment. Using electricity, again, might affect the environment slightly. A vertical displacement of a mass of 0.2 kilograms changes with time. The graph shows how this displacement changes. At which rate does it gain gravitational potential energy as it moves upwards? As it moves upwards, can I find the rate at which it gains gravitational potential energy? Yes, I can. You have the mass, right? What is the gravitational potential energy? It's mgh. mgh. Rate of gaining gravitational potential energy. Basically, he's asking about the power, because if you have the rate, so you need to divide by the time. So mgh over time. The mass is 0.2 kilograms, right? So 0.2 kilograms times the g, which is 9.8. You can use it as 10 since this is an old test. Okay, times the height as it's moving upwards. As it is moving upwards. So if we start from the bottom all the way to the top, it started at negative 2.5 and it ended at 2.5. Negative 2.5 centimeters to 2.5 centimeters. The total displacement is what is 5, right? If you find the difference between, it's not zero, it is 5. Why? Because 2.5 minus negative 2.5, this would be 5 centimeters. But you need to change this centimeters into meters. If you divide by 100, this would be 0.05 meters. So 0.2 times 10 times 0.05 divided by the time taken between these 2 points. What is the time taken between these 2 points? Let's see. From this point all the way to this point, 0.2, and then you add another 0.2 and another 0.2. So 0.24. 0.24. Okay? If you calculate this time, or if you calculate this power, actually it would be 0.2 times 10 times 0.05 divided by 0.24, giving you 0.41, or basically 0.4 watts. Okay, this is the power used by this object. Question 13 is cancelled. Parameters have been removed from the syllabus. Question 14, an oil tank has a base area of 2.5 meters, depth of 1.2 meters. The density is 800 kilograms per meter cubed. What is the force exerted? Can I find the force? Yes. If you can use both equations of the pressure. Force over area would be equal to rho g h. To find the force, it would be equal to rho g h times the area. Basically 800 times 9.8 or times 10. Okay, times 10 times the height, 1.2 times the area, which is 2.5, giving you a total force of 24,000 newtons. When molecules of gas rebound from the wall, they experience a pressure. What is the cause of this pressure? The change in momentum. You know that as they change the momentum, they cause a force. Question 16 is cancelled. Question 17, it's also cancelled. In 18, he's asking about which row is correct for the materials used for the base and the handle of the pan. The base should be a good conductor, while the handle should be a poor conductor of thermal energy. 19, he's asking about the amplitude and the wavelength. The amplitude is 1, while the wavelength is 8. Can I find the frequency? Yes, the frequency would be equal to the speed over the wavelength. The speed in the glass block is 2 times 10 to the power of 8, and the wavelength inside the glass block is 4 times 10 to the negative 7, giving you a frequency of 5 times 10 to the power of 14. Question 21, Scout P. He wants to reflect the light to Scout Q. You want the light to be reflected this way, right? So if you use D, a lot of you might say D is the correct answer. D is the wrong answer. Why? If you think about it, you have the normal line at this point. So when it's reflected, it would be reflected downwards this way. You do not want the light to be reflected downwards this way. This would be wrong. Okay? You want the light to be slightly reflected downwards, but in front of him, not just directly below him. Not directly below him. So D would be wrong. C is definitely wrong. B seems to be very close, but it's wrong. Why? Because B, the light will be reflected back towards the sun. So basically, you're reflecting the light back to where it came from, so it's wrong. Actually, A is correct. Again, if you draw the normal line, it would be reflected downwards with a small angle. So A is the correct answer. Which row describes real and virtual images of a point? Real images are formed where light rays meet. Don't they form where the light rays meet? Yes, they do. What about virtual images? An image in a plane mirror is an example of a virtual image, or can they project it? No, they cannot be projected on the screen. That's the definition of a virtual image. Yes, so A is correct. X, which statement is not correct? So you have a sound wave X. Okay, this is a rarefaction. Earlier there was a compression at X, probably yes. Later there will be a rarefaction at X. Again, probably yes, because this is a sound wave moving parallel to the energy motion. It's moving to the left and to the right. This part of the wave is traveling horizontally across the page, or is it traveling towards the top of the page? No, it's not traveling towards the top. It's traveling horizontally to the left or to the right. Diagram shows ranges of human hearing and ultrasound. To which characteristic of sound waves do the numbers on the diagram refer? They definitely refer to the frequency. We can hear certain frequencies. NP and NQ. Hmm. Permanent magnet. This is a soft iron bar, so it will be attracted. This has to be a south pole, and this has to be a north pole. Demagnetization is cancelled. It's removed. Okay, two power supplies are connected in separate circuits. Both power supplies provide the same magnitude current. Power supply P has an electromotive force of 1.5 and power supply Q has an electromotive force of 3 volts. Which statements are correct? Source Q supplies twice the charge per unit time. Don't they have the same current? They do have the same current. So if you say twice the charge per unit time, this is twice the current. So this is wrong. Source Q supplies twice the energy per unit charge. Energy per unit charge, which is the voltage. Yes, energy per unit charge. So 3, it's twice 1.5. So this is correct. Source Q supplies twice the energy per unit time. Again, yes, energy per unit time, because if you calculate the energy, or if you calculate the power, energy per unit time, P equals VI, yes, it's twice the energy per unit time. So this is correct. So D is the correct answer. So measures the potential difference. Which calculation gives the resistance of the device? Can I find the resistance? Yes, R equals V over I, right? R equals V over I. An electricity meter records 200 megajoules of electricity that are drawn from the 240 volts main supply in a 24-hour period. What is the average rate of electrical charge through the meter? Can I find the rate of electrical charge? Yes. Basically, he wants to find. Can I find the charge? How can you find the charge? How can you find the charge? If you have the energy and you have the voltage, okay, if you have the energy and you have the voltage, you can say, for example, you have several equations. One of them is the voltage is equal to the energy over the charge, right? So if you say energy, which is 200 divided by the voltage, giving you 0.83, okay, 0.83 mega coulombs per hour. Is this correct? No. Why? Because this is over a 24-hour period. So if you just say energy over, to find the charge, this would be energy over voltage. So 200 over 240, this will give you 0.83 mega coulombs, but not per hour. Huh? This is not per hour. This is per what? Per 24 hours. Per 24 hours. So if you want to find it per hour, you need to divide it by 24 again. Okay? You need to divide by 24 again. If you divide this number by 24, not 0.24, if you divide it by 24, okay, it would give you a very small number, 0.0347, 0.0347. But if you multiply this number by 1,000, this is mega coulombs. Again, this is mega coulombs. If you multiply it by 1,000 to find it in kilocoulombs, okay, if you multiply it by 1,000 to find it in kilocoulombs, this would be 34.7 kilocoulombs per hour, which is C. Okay, 34 kilocoulombs per hour. Okay. What is the resistance of this combination? To find the resistance, product over sum, which is 3 times 4 over 3 plus 4, 12 over 7, 1.7 ohms. What is the purpose of the circuit? You have a thermistor, so it has to do with the temperature. It has to do with the temperature. So the only one which has to do with the temperature is to sound a bell when the temperature rises. You have 2 voltmeters. What happens to the reading on P and to the reading on Q when X is moved towards the top of the diagram? As X rises, Q, the reading on Q increases and the reading on P decreases. Q increases while P decreases. Why? Because the arrow covers a greater portion of this resistor for Q and a lesser portion of the resistor for P. Q increases and P decreases. 33 is cancelled. 34, in which direction is the wire moved? In which direction? If you have an induced current, then you will use the Fleming's right-hand rule, right? Fleming's right-hand rule. So you'd find that the first finger is pointing from the north to south, and the second finger is pointing out of the page, somehow out of the page, and therefore the force, yes, okay, the force would be downwards. The force would be downwards, or C. The core has to be made of iron, while the coil has to be made of copper. That's easy. A solenoid is connected to a battery. Which statement about the magnetic field at the center of the solenoid is magnetic field at this point should be, if you want to draw the magnetic field, you draw it this way. You draw the magnetic field this way, and then around the solenoid it would be somewhat like this, right? Somewhat like this. So at this point, the direction of the magnetic field should be parallel to the axis. At this point, it should be straight lines as I've drawn them. Straight lines at this point. What is the name of the center? Nucleus. Orbiting particles, electrons. Only one type of radiation is present. So there is a magnetic field into the plane, right? There is a magnetic field into the plane. And then you have the direction of this particle. Definitely it's not a gamma particle. It's either an alpha particle or a beta particle, right? It has to be either an alpha or a beta particle. Now, radiation from the radioactive source passes between two metal plates and is deflected as shown in the diagram. Between the plates there is a magnetic field directed into the plane as indicated by the crosses. Only one type of radiation is being emitted. So it's either, let's cancel out gamma radiation. We will cancel. Why should I cancel out gamma radiation? Because the gamma radiation will not be deflected inside this magnetic field. If you have the magnetic field into the paper, so you'll use either the Fleming's left-hand rule or Fleming's right-hand rule. Okay, I do not know which. If I start off using Fleming's left-hand rule to find if it's alpha or not, Fleming's left-hand rule will indicate whether it is an alpha particle or not. It's into the page, so first finger is into the page. Second finger is pointing to the right. Now my thumb is pointing upwards, even though the force on this particle is downwards. If you try Fleming's right hand rule, you'd have the magnetic field first finger into the page, the second finger pointing to the right, and the force pointing downwards, indicating that this is definitely a beta particle, not an alpha particle. Okay, so there is a beta particle. The nucleus of an isotope of nitrogen N absorbs a neutron and then it decays into an isotope of carbon and emits X. What is X? Can I balance out this equation? Yes. The mass is the mass on the left hand side is 15. So the mass on the right hand side has to be 15 as well. Therefore, X has to be 1. Correct? And then the proton number on the left hand side is 0 plus 7, which is 7. So it has to be also 7 on the right hand side, so 6. And this has to be 1. What is 1 and 1? What is 1? It is a proton, right? It is a proton. Why? Because a proton has a mass of 1 and a proton number or a charge of positive 1, right? A graph shows how the decay rate is registered. Okay, you have a background rate of 5 counts per minute. Can I find the half-life? Yes, if you have the half-life, minus divide plus, right? Minus divide and plus. You start off with 45, so 45 minus 5 is 40. 40 divided by 2 is 20. 20 plus 5, 25. So from the 25 point, draw a line, giving you a half-life of 2 days.